All right, in this video, I'm going to cover power. So mathematically, the formula to determine power is pretty straightforward. It's work over time. And conceptually, it is the rate at which the external force changes the energy of the system. And so the units now of power is work is measured in joules, time is in seconds. 1 joule over second is equal to 1 watt. That's the unit of power. Now, it's a small unit, so we usually use kilowatts. And so 1 kilowatt is nothing else as 1,000 watts. Now, what kind of problems could be now presented with this concept? Well, let me read the problem. And so the problem is given here. Let me just start organizing everything. So you have a box that weighs 575 newtons. So this is, it has the weight, but the weight can be also expressed as a force. And the force here is 575 Newton here. And the next piece of information is lifted a distance of 20 meters straight up. So I have a height now of 20.0 meters. And it is also lifted, it tells me the problem here by the cable is attached. It's the motor is doing the work on this box. And the job is done. The job is done in 10 seconds. So I got here time, 10.0 seconds here. And the question is, what power is developed by the motor in the watts and kilowatts? Okay, so we need the power here. They want the units of kilowatts and watts. Okay, so how do we solve this problem here? Well, we know the formula for power is equal to W over T. I don't have work yet calculated, but the work is nothing else as the force times the distance from the previous discussion. I already introduced this formula here. So now, once you find the work, you plug in here into the original formula, and then you just find the power. Okay, so now the work here is equal to the force, 575 Newton, times the distance that this object was moved upwards, 20.0 meters. And again, Newton is nothing else as a kilogram times meter over second square. So you got times another meter here. So now units will be here simply now kilogram meter square over second square, which is nothing else as a joule. So let me just get the answer here. So I'm going to plug in 575 times 20. I got 3 significant figures in both numbers. So I got something like 1.15, 10 to the positive 1, 2, 3, 4. I move 4 times the decimal. And that will be joules now. Okay, so I found the work. So how do I find the power? Well, the power is nothing else. Again, we just talked about it. It is the range, the rate at which the external force changes the energy of the system. And so the rate here, of course, the work over time. So it gives you per certain time, the work is changing. The system. Okay, so now my next move will be P is equal to W. I know now my W, 1.15, 10 to the positive 4 joules over 10 seconds, 10.0 seconds. Again, I have 3 significant figures in both numbers. So, and again, the joule over second, I just define it as watts. So I'm going to get W straight from this calculation here. I'm going to divide. I don't really need the calculator here, so I just have to reduce it by 10 in here. This number is going to be 1.15, 10 to the positive 3 now here. So that will be the answer in watts. Now, what is the answer here in kilowatts? And again, power is equal to, you're going to state what's given here to the third power, watts times, the conversion factor is that 1 kilowatt is equivalent to 1,000 watts. Canceled. So now this is 10 to the positive 3. This is 10 to the positive 3. They both cancel. And so the final answer will be just 1.15 kilowatts. And again, what we just found is what's called the power. And the power, again, is nothing else. It's just the rate at which the external force changes the energy of the system. And so what's being changed in here? So the I guess the force was acted on the box, and it was moved with a certain force. I did some work during this move per certain time, and that's what power is.